Picture this. You're about to leave for work when suddenly your future self bursts through the door, warning you not to take your usual route. Sounds like something straight out of a sci-fi movie, right? But what if I told you that time travel might not be as far-fetched as you think? Hey, everyone. Welcome to our channel. Today, we're diving into one of science's most captivating questions. Is time travel possible? Time travel is the concept of moving between different points in time, much like we move between different points in space. It's a staple of science fiction, popularized by stories like H.G. Wells's The Time Machine, where characters use a device to journey to the past or future. But what does it really mean to travel through time? In scientific terms, time travel can be defined as an object's movement through time in a way that the difference between its departure and arrival times in the surrounding world does not match the duration of its journey. For instance, if you were to travel in a spaceship for an hour according to your clock, but 2 hours had passed on Earth, you would have effectively traveled through time. There are two main types of time travel: traveling to the past and traveling to the future. Traveling to the future is something we experience every day, moving forward at a constant rate of 1 second per second. However, the concept of traveling to the future at different rates is supported by Einstein's theory of relativity. For example, astronauts on the International Space Station age slightly slower than people on Earth due to the effects of time dilation. Traveling to the past, on the other hand, is much more controversial and complex. While some solutions in general relativity, such as rotating black holes or wormholes, suggest it might be theoretically possible, it raises numerous paradoxes and challenges. One famous paradox is the grandfather paradox, which questions what would happen if you traveled back in time and prevented your own existence. Time travel is often misunderstood, thanks in part to its portrayal in movies and TV shows. One common misconception is that time travel would allow us to freely change the past or future. However, many theories suggest that even if backward time travel were possible, it might not be possible to alter events due to principles like the Novikov self-consistency principle, which proposes that any actions taken by a time traveler were always part of history. The science behind time travel. Albert Einstein's theory of relativity fundamentally changed our understanding of time and space. According to this theory, space and time are intertwined into a single continuum known as space-time. Instead of viewing time as a constant, Einstein proposed that time can be affected by speed and gravity, leading to phenomena such as time dilation. Space-time can be visualized as a fabric that can be warped by massive objects. Imagine placing a heavy ball on a trampoline. The ball creates a dip in the fabric. Similarly, massive objects like planets and stars create curves in space-time, which we perceive as gravity. This curvature affects the passage of time, causing it to slow down near massive objects, a concept known as gravitational time dilation. Time dilation is a fascinating consequence of relativity. It means that time passes at different rates depending on the relative speed and gravitational field of an observer. For example, astronauts on the International Space Station experience time slightly slower than people on Earth due to their high velocity and lower gravitational field. This effect has been confirmed by precise measurements using atomic clocks. While Einstein's relativity deals with the macroscopic world, quantum mechanics governs the microscopic realm of particles. Quantum mechanics introduces concepts that are often counterintuitive, such as particles existing in multiple states simultaneously and being intrinsically linked through entanglement. Quantum entanglement is a phenomenon where particles become interconnected in such a way that the state of one particle instantly influences the state of another, no matter the distance between them. This spooky action at a distance, as Einstein called it, has led some physicists to explore its implications for time travel. For instance, manipulating entanglement could theoretically allow for simulations of backward time travel, where information from the future influences the past. One intriguing idea is the use of closed time-like curves, which are loops in space-time that could theoretically allow for time travel. In quantum mechanics, researchers have explored how particles might behave in these CTCs, potentially resolving paradoxes like the grandfather paradox through principles such as the Novikov self-consistency principle. This principle suggests that any actions taken by a time traveler were always part of history, thus avoiding contradictions. Wormholes are theoretical tunnels through space-time that could potentially create shortcuts for long journeys across the universe. Imagine the universe as a sheet of paper. A wormhole would be like folding that paper so two distant points touch, allowing you to step from one to the other instantly. In theory, wormholes could be used for time travel. If we could create a wormhole with one end remaining stationary and accelerate the other end to near light speed, time dilation would cause the moving end to age more slowly. This time difference between the two ends could potentially allow for travel into the past or future. However, there's a catch. While wormholes are mathematically possible within Einstein's theory of general relativity, keeping them open would require negative energy, which is currently beyond our technological capabilities and may be physically impossible. Additionally, even if we could create a stable wormhole, the intense gravitational effects might make it impossible for anything to pass through safely. Cosmic strings are another theoretical construct that could potentially enable time travel. These are hypothetical one-dimensional defects in the fabric of space-time, thought to have formed in the early universe. They would be incredibly thin, about the width of a proton, but also unimaginably dense, with significant gravitational effects. Physicist J. Richard Gott proposed in 1991 that these cosmic strings could be used for time travel. The idea is that two cosmic strings, or a cosmic string and a black hole, moving past each other at high speeds, could warp space-time enough to create closed time-like curves, paths through space-time that loop back on themselves, potentially allowing for travel into the past. However, the energy requirements for this method of time travel are staggering. Gott himself calculated that to travel back in time by just 1 year would require a loop of cosmic string containing half the mass energy of an entire galaxy. Popular culture is full of time machines, from H.G. Wells's Victorian-era device to Doc Brown's DeLorean in Back to the Future. However, the scientific basis for these concepts is tenuous at best. In reality, any time machine would likely involve manipulating space-time itself rather than a mechanical device. The closest scientific concepts we have are the theoretical possibilities discussed above: wormholes and cosmic strings. These aren't machines in the traditional sense, but rather extreme manipulations of the fabric of the universe. It's important to note that while these concepts are mathematically possible within our current understanding of physics, they face enormous practical and theoretical challenges. The energy requirements are astronomical, the technology needed is far beyond our current capabilities, and there are serious questions about whether the universe would allow such manipulation of causality. The grandfather paradox is one of the most famous thought experiments in time travel. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. This would mean you were never born. But if you were never born, how could you travel back in time to prevent your grandparents from meeting? It's a classic logical contradiction that arises from the concept of changing the past. This paradox isn't limited to family scenarios. Any action that changes the past in a way that prevents the time travel from occurring in the first place creates a similar contradiction. For instance, what if you went back in time and prevented the invention of the time machine you used? In conclusion, While time travel remains a fascinating topic in both science fiction and theoretical physics, the practical realization of a time machine remains firmly in the realm of speculation. However, exploring these ideas continues to push the boundaries of our understanding of the universe and the nature of time itself.